2 times 0 would be 0. 3 times 0 is 0. So 0 plus 0 would be 0. And we have 0 greater than 6. 0 is not greater than 6, so this is a false statement, which means the point we selected, 0, 0, does not work, which means we'll shade the opposite side of the line. And that would be the graph for the inequality. Second question, and last question for this section. Y is less than or equal to 2x minus 4. Again, there's many ways to graph lines. This inequality is in mx plus b form. Mx plus b form means y is by itself, and you have slope-intercept form on the right-hand side. In this case, m, the number in front of x, would be 2, and b, which is the y-intercept, the last number is negative 4. When you have the slope and y-intercept, you can graph using those 2 points. Start at the y-intercept, which is negative 4. On the y-axis, the graph will start at negative 4. The slope m equals 2. We can make a fraction 2 over 1. So the rise over run will be up 2 spots and over 1 spot. Going up 2 from negative 4 and to the right 1 spot, we'll have the 2 points. Looking back at the inequality, this is less than or equal to. Since it's or equal to, this will be a solid line through the 2 points. And the last part, since it is an inequality graph, we will shade one side or the other side of the line. And again, one way to tell is use a test point. You can use any point on the graph, but 0, 0 is usually a good point to use. Plugging 0, 0 into the original question, we have 0 is less than or equal to 2 times 0 and minus 4. So 0 is less than or equal to 2 times 0 is 0, minus 4 would be negative 4. So we have 0 is less than or equal to negative 4, which is a false statement. If it does not work again, that means the point 0, 0 is not shaded, but instead you go to the opposite side and we'll shade the opposite side of the line that does not contain 0, 0. Title of the last section today is Graphing Absolute Value Inequalities. In this section we'll be graphing inequalities on a xy axis, and the inequalities will contain absolute values. The first question, y is greater than or equal to the absolute value of x. Again, to graph absolute values, one easy way is to take what's on the inside of the absolute value and set that equal to 0. So x equals 0, and you can do a t-table with just that single point for x equals 0. Plugging a 0 in, absolute value of 0 is 0, so the y value would also be 0. Graphing this on the xy axis, 0, 0 would be in the middle of the graph. Absolute values, again, are a V shape. This is a positive absolute value, so it's a V shape that opens up. It's also greater than or equal to, so the lines are solid lines. And the last part for an inequality graph is shading. For an absolute value graph, we'll either shade inside the V or we'll shade everything outside the V. Like the previous section, we can use a test point. The difference on this graph is 0, 0 is on the line of the graph. When you do a test point, the test point has to be on one side or the other side of the line, but it cannot be on the line. So for example, we can use a point below 0, 0. We can use a point 0, negative 1. Plug in the values 0, negative 1 into the original question. The y value would be negative 1, greater than or equal to the absolute value x, which we'll use a value for 0. So we'll have negative 1 is greater than or equal to 0. Negative 1 is not greater than or equal to 0. So again, the point we used, negative 1, 0, does not work for the graph, which means we're not going to shade that point, but instead we'll go to the opposite or inside the graph, and we'll shade inside the absolute value. And that would be the graph for the inequality. Second question is y is less than the absolute value of x and plus 1 outside the absolute value. Again, using a t-table, we can use a single point. We'll set x equal to the inside, which is just 0. So again, using a t-table, we can use just a single value for x equals 0. Plugging it into the equation, the absolute value of 0 would be 0, plus 1 would make the y value 1. So graphing on a xy axis, we'll graph the point 0, 1. And again, the absolute value is positive. There's no negative number outside the absolute value. So this will be a V shape pointing up. The inequality is less than. If it's less than, it is a dashed line, but still a V shape. And last part again, we'll shade either inside the absolute value or outside the absolute value. For test points, you can use any point on the graph, but again, that point cannot be on the line that you graphed. In this case, we can use 0, 0 since it's below the graph. Plugging 0, 0 into the original question, we have 0 is less than the absolute value of 0 plus 1. Solving this, we have 0 is less than the absolute value of 0 would be 0 plus 1 would be 1. So we have 0 is less than 1, which is true. If it's true, it means the point 0, 0 is part of the solution or the part of the graph that's shaded, which in this case is outside the absolute value. So we'll shade everything that is outside the absolute value. And that would be the answer for the graph. Last question for the section is y is greater than 2 times the absolute value of x and minus 3 outside the absolute value. Again, graphing this, we can take the absolute value, in this case it's x, set that equal to 0, so we'll use just a single point for the xy table, x equals 0. Plugging a 0 in, absolute value of 0 would be 0, times 2 would be 0, and minus 3 makes the y value minus 3. Graphing from here, we have the point 0, negative 3. The absolute value again is being multiplied by a positive number, or positive 2, so the absolute value v would be pointed up. The inequality is greater than, which makes this a dashed line. And last part's shading, which will either be inside the absolute value or it'll be outside the absolute value. Again, we can use the test point 0, 0 since it's not on the absolute value line. Plugging it back into the original question, we have 0 is greater than 2 times the absolute value of 0 minus 3. Simplifying, 0 is greater than, absolute value of 0 is 0, times 2 is 0, minus 3 is negative 3. So 0 is greater than negative 3, which does 0 is greater than negative 3, which means the point 0, 0 is included in the solution and gets shaded. So in this case, everything inside the absolute value would be shaded. And that would be the graph for the question.